Now that we've discussed the anatomical structures of the respiratory system, we can now begin more of a dive into the physiological aspects of breathing. There are three main topics that we're going to be talking about: ventilation, external respiration, internal respiration, and how all that works. But in this video, we're going to focus primarily on ventilation. Ventilation is moving air into your lungs and out of your lungs, out into the wild blue yonder, whether you be in your room, whether you be outside, what have you. Getting that air into your lungs so that you can get that oxygen in, and then pushing out air to get rid of that extra carbon dioxide that you've produced. The terms that we care about for that for now is inhalation. To inhale means to breathe in. Exhale means to breathe out. All of which is determined by the respiratory muscles. The governing principle, physics principle, for you being able to breathe is called Boyle's law. The fancy way of saying Boyle's law is saying that the volume of gas is inversely related to the pressure that it exerts. The less fancy way of saying it is you give air is, I'm going to use while describing this image here. Gas molecules, they like space. They really do like space. It's in a closed system. We're in the world. You squish down that space, you remove that space, they're not happy. So they're going to put on pressure. They're going to be pushing a lot harder. If you increase that volume, though, you increase it a lot, you give them a lot of free roaming space, it decreases that pressure even further. Another way to think of it is when you're thinking of a car tire or a bike tire. You're putting in air into that bike tire, you're putting air into that car tire, more and more and more. Lots and lots and lots of air. More air molecules equals more volume, but you're not giving it more space, even though you are adding more people to it. Then it's going to start getting tight quarters and they're going to start pushing on that tire, hence why the tire becomes hard. The pressure inside that tire can be relieved if you push on the gas valve on the outside, or if somebody decides to pop their tire. In the lungs, what we do, or how we pull air into our lungs, is by increasing the volume of the thoracic cavity. Now, how do we do that? The diaphragm, when it's relaxed, is curved upwards into the thoracic cavity. When you contract it, you are pulling it taut. You're no longer letting it bow anymore, which increases that volume. And if you remember, more volume means less pressure, and the pressure on the outside being more is going to get sucked in. It's just like the people back in the olden days when they crossed the plains, they're looking for elbow room. They're looking for space. They heard there's space in here, so they've migrated in here. So that pulls in air. But how do you push air out? Well, if you relax that diaphragm is going to go back to relaxing that curved position, which means there is less volume of space in your thoracic cavity, which means you have less elbow room and more pressure builds up. If you have more pressure in your lungs than on the outside, air is going to escape out. Okay, you're going to exhale. Now, there are other muscles that are involved in inhalation and exhalation depending upon your situation. If it's relaxed breathing, it's just your diaphragm with a tiny bit of external muscles. If you've got labored breathing, you're going to include the diaphragm, you're going to include the external intercostals, you're going to include the scalenes and sternocleidomastoid. These are the muscles of inhalation. This is when you are forcibly inhaling. Notice that every single one of these muscles during a forced inhalation are working together to increase the volume within your thoracic cavity. The external intercostals, the way that they're lined up and their striations are lined up, it pulls on those ribs and pulls them out a little bit further, thus increasing that thoracic cavity space. The scalenes and sternocleidomastoid, pull on the mandible. Ugh, I'm brain farting on there. The mandible, we're going to call it for now. I'm going to kick myself in the head later, as well as the clavicle here, are all getting pulled up, and by pulling up, it gives it even more space in that thoracic cavity, thus increasing the volume and thus increasing even more air molecules going into your lungs. Again, that diaphragm, here's a side picture of that diaphragm doing its thing. It uncurves a little bit, increasing that thoracic space. The muscles of exhalation, by the way, aren't going up. They're more in your abdominal region. When you're trying to force air out, your internal intercostals are now forcing air out of your lungs. It's pulling on those ribs in such a way that it's decreasing that volume. Those ribs encroach or invade that thoracic space and push air out. You can also really help push up that diaphragm by pulling on your six-pack, your rectus abdominis, as well as your obliques. Will work on it by pushing up that diaphragm a little bit faster. Your external obliques will also pull on your ribs to pull them closer to your midline to also decrease that diaphragm, the space within that thoracic cavity, thus making a quicker, faster exhalation. There are other factors in your ability to ventilate, your surface tension back in your terminal bronchi. Again, if you don't have that surfactant there, it's going to stick there really well, and it's not going to open up. Surface tension also makes it harder for oxygen, even if the alveoli are opened up. The surface tension can make it hard for O2 to cross that surface tension that's a little bit greater. Thus, surfactant is useful in that sense as well. Elastic recoil, you want your alveoli to be able to return to size during expiration and go back, kind of like you got going on in your arteries in that pressure reservoir. You also got compliance, as well as are your lungs and thoracic cavity willing to expand. Terms for describing the breathing patterns. Eupnea, oh, I clicked the wrong button. Eupnea. Apnea is the lack of breathing. Remember that A in front of any word in anatomy and physiology usually, almost always, indicates no or non-existing. So apnea refers to no breathing. Dyspnea refers to difficulty breathing. When you have a utopia, eupnea, you have a normal society, you have a good society. You have good breathing here. With dyspnea, forgive me, not dyspnea. Dyspnea, it's just like a dystopia. It's difficult, it's truculent, it's awful, it's dystopia is an awful place to be in. Dyspnea is difficult breathing. Tachy should sound familiar from when we're talking cardiac tissue. When we say tachycardic, we're talking about somebody with a quick heart rate. Tachypnea, I keep on doing that, is rapid breathing. Costal breathing is characteristic of breathing using entirely your intercostal muscles, trying to work on it. It's significant of labored breathing. You got diaphragmatic breathing as well, which means you can see these types of disorders in children and infants and that are having difficult breathing, where you see the belly swell often and frequently. We're not going to, I don't think we need to care anything about any of these. We're just going to go ahead and move on to the last bit about this that's going to be contained in this video about the control of ventilation. Why be tachypneic, or why breathe hard, why breathe fast, all that stuff. If you remember back to AMP2, we had discussed that this portion of the brain, the brain stem, has a lot of control over your vital functions. This holds true here. If you notice in the medulla oblongata, we have a couple of major areas going on here that control it. Let's go ahead and break down these areas really quick. First off, you have the dorsal respiratory group located in the medulla oblongata. The dorsal respiratory group is your relaxed breathing. And the only time that when it becomes activated is when you're actually breathing or pulling in air. It signals to your diaphragm to contract. It also tells your external intercostals to do their job a little bit, and they become active. When it becomes inactive, this dorsal respiratory group becomes inactive. All the muscles that it just triggered are no longer being told to do their thing, and they all relax, which means that you get a nice quiet exhalation. But what happens when you go out exercising or you get a sympathetic nervous response and you got to run and run hard? Or you got some other type of issue requiring you to expend air quickly? Well, the dorsal respiratory group is still doing its thing. It is the head control of breathing, but it's also going to recruit a helper called the ventral respiratory group. This portion over here is talking about inhalation. This portion over here is talking about exhalation. Let's focus on inhalation first. Dorsal respiratory group, of course, is just going to keep on doing its thing with trying to control the diaphragm and external intercostals for inhalation, but it's also recruiting the front respiratory group, ventral respiratory group, to also recruit that sternocleidomastoid, those scalene muscles, as well as the pectoralis minor muscle to really help expand those ribs quickly and that thoracic cavity volume quickly. If you remember, the dorsal respiratory group takes an inactive role in allowing for exhalation. But in labored breathing, you don't have that option to let it just relax by itself. So you need other muscles to really help push that air out. So that ventral respiratory group also is recruiting muscles for exhalation. That's your internal intercostal muscles, your external obliques, the internal obliques, your six packs, the transversus abdominis and rectus abdominis, not the transversus abdominis for six packs, forgive me, the rectus abdominis muscles, all of which are there to help move those muscles, those relaxing muscles, to go faster and decrease that thoracic volume. This one I'm actually going to make its own video because it's a lot of detail and I'd hate for it to get lost at the end of this video. With that, let's go ahead and see you next time.